11.2 goes over dividing monomials. When we are dividing these, we're going to start by just simplifying our fractions that we have here. So if we look at example 1, we have for A, 15 over 21. We're just simplifying. These are both divisible by 3, so we would divide both of them, the numbers, by 3 to give us 5 over 7. For example B, we have 35 over 90. We can divide both of these by 5 to start with. The 35 divided by 5 is 7. And the 90 divided by 5, 5 goes into 9 one time with 4 left over. 5 goes into 40 8 times. So that's 7 over 18. For example C, we have 27 over 343. Your factors of 27 are 3 and 9. The 9 is 3 and 3. So if 3 goes into 27, 3 would have to go into 343 as well. It does not go in evenly. So this fraction that is 27 over 343 is in simplest form. And for example D, we have 54 over 108. These are actually both divisible by 54 because 54 times 2 is 108. So this is just 1/2. For our next set of examples, we're looking at these in a different way. So we can rewrite these as a product for each of these numbers. When you do that, if your factor is the same on the top as it is on the bottom of that fraction, they cancel each other out. So if we look at example A, we have 35 over 42. 35 is 5 times 7. 42 is 6 times 7. There is a 7 on the numerator and the denominator of this fraction, so those would cancel each other out, and we would be left with just 5 over 6. For example B, we have negative 4xy over 10x. That negative 4, we can represent that as negative 1 times 2 times 2. We also have an x and a y up top. The 10 on the bottom is 2 times 5, and we have that x on the bottom as well. You have a 2 on the numerator and the denominator. You have an x in the numerator and the denominator. So from here, you multiply what's left over once you cancel those out, and you just have negative 2y over 5. For example C, we have 16x over 8y. That 16 is 2 times 8. The 8y is just 8 times y. The reason why I don't separate this any further is because I do have my like factors of 8 in the numerator and the denominator, and they would cancel out, so that way we just are left with 2x over y. For example D, we have 56y over 34x. That 56, if I divided it by 2, it gives us 2 times 28 times y. And in the denominator, the 34 divided by 2 is 14, so it's 17. So that's 2 times 17 times x. The reason why I don't simplify these any further by finding the other factors of 28 are because the only thing that cancels out are the 2's. 28 is not divisible by something that gives you a 17, so you will not be able to cancel anything else out. So we are just left with 28y over 17x. For the next set of examples, we are just simplifying. When you are dividing monomials that are variables raised to powers, if the variable is the same in both the numerator and the denominator, you are going to subtract the variables, and if you are left with a number that is positive, you are going to subtract the exponents. If you're left with a number that's positive, that variable stays up top in the numerator of the fraction. If you're left with a negative exponent, that variable goes to the bottom with that exponent of the fraction. So if we look at example 3a, we have c to the 7th power over c to the 4th power. Our variable is the same in the top and the bottom of our fraction. So we're going to keep the variable and we're going to subtract those exponents. 7 minus 4 is 3, so that's c to the 3rd power. That 3 is positive, so we leave it the way that we have it. For example b, we have a to the 3rd power over a to the 8th power. So our a is the same in the numerator and the denominator, so we keep a. We subtract the 3 and the 8. 3 minus 8 is negative 5, so that's a to the negative 5th power. In order to turn that power to be a positive, because you cannot leave a negative power in your answer, you have to take the reciprocal of the term, and that will turn that negative power into a positive power. So this becomes 1 over a to the 5th power. For example c, we have b to the 5th power over b to the 5th power. If we keep the b, since it's the same in both the numerator and the denominator, and we subtract those powers, we are left with b to the power of 0. Our rule with an exponent that is 0 is that anything raised to the power of 0 turns into a 1. So this simplified is just the 1. For example d, we have x to the 9th power over x to the 11th power. Our x is in the numerator and the denominator, so we keep x. We subtract those powers. 9 minus 11 gives us x to the power of negative 2. We cannot keep a negative power, so we do have to take the reciprocal of this, and it gives us 1 over x squared. For our next set of examples, we are still just simplifying. For example 4a, we have x to the 9th power over x to the 5th power. So again, our variables are the same in the numerator and the denominator. We keep the variable and we subtract those powers. 9 minus 5 is 4, so that's x to the 4th power. For example b, we have x squared over x to the 7th power. Again, we're going to keep the x and subtract those powers. 2 minus 7 gives us negative 5, so x to the negative 5th power we need to take the reciprocal of, and it just gives us 1 over x to the positive 5th power. For example c, we have x cubed over x cubed. Again, if we keep the x and we subtract those powers, it gives us x to the power of 0, which anything to the power of 0 is 1. For example 5, we are finding the greatest common factor. For example a, we have 72x cubed y z cubed and 120x squared z to the 5th power. With these, if we have variables that are raised to powers, we're going to keep the variable with the smallest power. If the variable is not the same for both terms, we do not include it. So if we look at 72, we have 1 and 72. 2 goes into 7 3 times with 1 left over. 2 goes into 12 6 times. 3 goes into 72. 3 goes into 7 2 times with 1 left over. 3 goes into 12 4 times. 4 goes into 72 18 times. 5 does not. 6 goes in 12 times, and 8 goes in 9 times. For 120, we have 1 and 120, 2 and 60, 3 and 40, 5 and 24. Let me check that. Oops. Yeah, 5 and 24, 6 and 20. 7 does not go into 120 evenly. 8 goes in 15 times. 9 does not go in evenly. And 10 goes in 12 times. So your greatest common factor between these, if we look at the smaller of the two numbers, the 24 goes into both of these numbers evenly. Now, because these 24s go into both of these evenly, we're going to keep the 24, and then you want to look at your variables with these powers. You have an x for both of these numbers. The smaller power is x squared, so we're going to keep the x squared. You do not have a y for both of these numbers, so do not include the y in your answer. However, you do have a z in both of these numbers, so keep the z with the smaller power, which is z cubed. So 24 x to the second power, z to the third power is our greatest common factor between these two numbers. For example, B, we're given 35x to the sixth power, y to the fourth power, and 75x to the fourth power, y to the sixth power. For this one, that 35 is 1 and 35, as well as 5 and 7. The 75, we have 1 and 75. 5 goes into 7 one time. 5 goes into 25 5 times. That 75 is also divisible by 3, which gives us 25. From here, these are our only factors of 75 and 35. So your greatest, that is the same for both, is the 5. So we keep the 5. From there, you have an x in both numbers. The smaller power is the 4, so keep the x to the fourth power. You have a y in both of these numbers as well, so keep the 1 with the smaller power, which is y to the fourth power. So 5x to the fourth power, y to the fourth power is our answer. For our last set of examples, we are just simplifying these fractions. For example, 6a, we have 35x to the third power, y, z to the sixth power, all over 56x to the fifth power, y, z. With both of this 35 and this 56, you can divide them both by 7. So if we divide both of these by 7, we have 5 and we have 8. For your x, here, let's do this a different way. It's going to say 5 over 8. Your x values, you have an x in the top and an x in the bottom. So that's x to the third over x to the fifth. You have a y in the numerator and the denominator. Both of their variables are 1. So it's just y over y. And then you have a z in the numerator, which is z to the sixth, and z in the denominator, which is just z, or z to the first. If we subtract our exponents, this is going to give us x to the third minus the fifth, y to the first minus the first, and z to the sixth minus the first. This is going to leave us with x to the negative 2, y to the 0, and z to the fifth power. That y to the 0 is going to cancel out because it's just going to be a 1. That x to the negative 2 goes underneath. That z to the fifth power stays up top. So we're going to have 5z to the fifth power over 8x squared. For example, B, we have 64x cubed y squared all over 88xz. So that 64 and that 88 are both divisible by 8. This is going to leave us with 8 over 11. You have an x in the numerator and the denominator. That's going to be x cubed over x. You have a y in the numerator, not in the denominator. And then you have a z in the denominator, but not in the numerator. From here, we're going to subtract these powers if we need to. So that x cubed over x, we're going to subtract 1 from that 3, and that gives us x squared over 1. We have y squared over 1 still, and 1 over z. So if we multiply all of this together to give us our final answer, we're going to have 8x squared y squared all over 11z. And for our last example, C, we have 27xy to the fifth power, z to the seventh power, all over 18x to the fourth power, y squared, z to the ninth power. Your 27 and your 18 are both divisible by 9, So we can divide both of these by 9. This is going to give us 3 over 2. You have x in the numerator and x to the 4th power in the denominator. You have y to the 5th power in the numerator, y to the 2nd in your denominator, z to the 7th in the numerator, and z to the 9th in your denominator. This here, we are going to subtract our exponents. So the x to the 1st minus the 4th, the y to the 5th minus the 2nd, and z to the 7th minus the 9th. This gives us x to the negative 3rd, y to the positive 3rd, and z to the negative 2nd. The x to the negative 3rd becomes x cubed if you bring it to the denominator. The y cubed is going to stay up top, and that z to the negative 2nd is going to become z squared if you bring it to the denominator. So we're going to have 3y cubed over 2x cubed z to the 2nd power. Let's do this a little differently. 2x cubed z to the 2nd power. There we go.